Well, twofold. The difference is going to be that the equations we end up solving will be quadratic. That's not really the difficult part of the problem. The problem becomes when, we'll just dive right in, when the argument is quadratic. Okay, let's just set this up. We're going to remove the absolute value signs and write x squared minus 2x equals 1. And then we have to put a subdomain. But this subdomain here, this subdomain is going to be where x squared minus 2x is greater than or equal to 0. And if you had, like you did on the quiz, one version of the quiz had an absolute value of 5 minus 2x. The other version of the quiz had an absolute value of 4 minus 2x. Okay? But let's just forget about this for a second, that we had 5 minus 2x is greater than or equal to 0. Rearranging that is like stealing candy from a baby. I mean, the baby's a little feisty. You got to do a bit of work, but it's not that bad. You move the 2x over and you have 5 is greater than or equal to 2x. You divide both sides by 2, so you end up with 5 halves is greater than or equal to x, and you turn that around and you say that. And that statement, x is less than or equal to 5 halves, is what you would put in the subdomain. But you can't rearrange x squared minus x is greater than or equal to 0. It's not possible. So we have to determine the subdomains in a different way. Now in the next unit we're going to learn some strategies for doing this, but I'm going to go to a new page now. If we want to determine where x squared minus 2x is greater than or equal to 0, then what we're going to do is imagine that this is a graph. We're going to imagine y equals x squared minus 2x and graph it so we can determine where that thing, y, is greater than or equal to 0 or where it's less than or equal to 0 or less than 0. In fact, we did this when we did piecewise functions. I'm just reminding you that we're not using an algebraic approach. This expression factors into x minus 2, and what that means is that there is an x-intercept of 0 and an x-intercept of 2. We're going all the way back actually to, well, the last 2 units, because we didn't really learn and talk about the factoring and setting this equal to 0. We kind of did that in the first unit, but we also did it a bit in the second unit. The bottom line is those x-intercepts are at 0 and at 2. We also reach back into the unit before, and since this was positive x squared, we know this parabola would open up. So what good is that? Well, that's telling us where x squared minus 2x is greater than or equal to 0. X squared minus 2x is greater than or equal to 0 here, here, and here and here. Those 2 dots are where x squared minus 2x is equal to 0, and the 2 lines that are highlighted in yellow is where that x squared minus 2x is greater than 0. So what is the subdomain? What is the solution to this? I want to go back and show you something. If I said, what is the solution to this? The solution to this is that statement. Are you with me on that? We're just rearranging a linear inequality. So The solution is talking about x. The solution to this would be x is less than or equal to 0 and x is greater than or equal to 2. Look at the graph. Where is the graph greater than or equal to 0? Whenever x is 2 or to the right, and wherever x is 0 or to the left. And this is the more difficult aspect now of solving these when you have a quadratic. If we go back now, our subdomain is this. X is less than or equal to 2, x is greater than or equal, 0, and x is greater than or equal to 2. But the thing is, and this is maybe the thing that will be a relief to you, although, like on your quiz, you need to show your work on getting the subdomain, I don't care how you get this subdomain. I really don't. Because we haven't officially learned how to do this yet. We do that in the next unit where we deal with quadratic inequalities. It may even be the unit after that one. So when you're dealing with a quadratic, the subdomains are not important if the quadratic is in the absolute value signs. What does this mean now? It also means that we have this equation, negative 1 times x squared minus 2x equals 1. But it's got to be everywhere else. So if you imagine that my nose is the origin, we're saying that the first equation is valid here and to the left. If you imagine that this finger is the number 2, we're saying the first equation is valid from here and to the right. That means we have this gap in between those two. We have the gap in between this domain that's in the first equation and this domain that's in the equation, and the gap is here. Which means we can write 0 is less than x, which is less than 2. But the heavy lifting is done. If you can solve either of these equations, all you have to do is ask yourself whether it's in the subdomain or not to validate the equation's solution. So I'm going to tackle equation 1 first. Equation 1 is x squared minus 2x minus 1 equals 0. I mean, I have to zero the equation because it's quadratic. Is this factorable? Are there two numbers that multiply to give negative 1 and add to give negative 2? I don't think so. If it were plus 1 at the end, it would factor into x minus 1, x minus 1. This doesn't factor. So what do? Do we just give up and go home? No. Because we know how to solve these equations with the quadratic formula. So x will be equal to negative b, which is 2, plus or minus, well, you do this for me. Figure out for me what the value of the discriminant b squared minus 4ac is equal to. I want to say 8. Okay. All over 2a, which is 2. I like this example because it's incorporating a lot of the stuff from previous units. There's the quadratic formula. Well, we also know that root 8 is 2 root 2 because 8 is 4 times 2. Root 8 is root 4 times root 2. Root 4 is 2. We also know that I can factor a 2 out of the numerator and get 2 times 1 plus or minus root 2 over 2. We also know that these two 2's cancel. So what is the solution to case 1, the first equation? The solution is x equals 1 plus root 2 and x equals 1 minus root 2. Unlike your quiz, where I think the solution was negative 1. on both versions of the exam. I'm pretty sure it was -1. And you had another solution, but it was not valid, right? Unlike the solution on your quiz, this is irrational. Now we have to decide whether they're in the right domain. And to help you out here, many of you will not need to do this. However, and I told the same thing to my Math 30s this morning, so it's not just because you're only in grade 11. Many of you would benefit from writing this out on a number line. What does that mean? It means that if this is 2, x can be equal to 2 or greater than 2. And if this is 0, x can be equal to 0 or less than 0. To me, and I have to do that in order to sort certain things out. We were dealing with a different application of this morning. It had to do with logarithms, but I need to see a number line. So what is 1 plus root 2 approximately on your calculator? I want to say 2.41. Is 2.41 in this domain? Yep, it's greater than 2. 2.41 is a solution. Don't know what I did there. Where did it go? There it is. I hate it when that thing comes up. 2.41 is in the domain, so this is a solution. What about 1 minus root 2? Approximately in decimal form, it's negative 0.41, I think. And we look at this domain for the equation that we just solved. Negative 0.41 is in the domain. So this has 2 solutions. That first equation has 2 solutions. Let's look at the second equation now. Don't forget, everybody, all of this work here, everything we've done, with the exception of writing this down, everything we've done is just one of the equations. Right? Now we have to look at this. So we're going to solve that equation. Let's see what happens there. Well, you can organize your space however you like. I'm going to write this on the right-hand side of my page where I've got a little bit more room. My second equation is negative x squared plus 2x equals 1. So I've multiplied this through. I'm going to zero the equation by moving all of the terms to the right-hand side. Is this equation factorable? This time it is. It factors into x minus 1 times x minus 1, which means x minus 1 equals 0, which means x equals 1. That was easier. X is equal to 1. Now, listen, I know you don't have to do this, but I'm going to. I'm going to put a number line here for this. And the number line for this is from 0 to 2, but it's in between them. Is the solution that we get here, which is 1, in between 0 and 2? Yes. So we have a third solution. Let's just check something out now. Grab your graphing calculator. And let's solve this graphically. Okay. The absolute value of x squared minus 2x equals 1. I think Zoom Standard, I think Zoom Standard should do the trick. If not, we can adjust that later. I'm going to zoom in using the box feature. It's always satisfying to see a visual. This is not how we want to do the math, but it's always satisfying to see a visual and boost our confidence that we did the math properly. I can see 3 points of intersection there. And if I find the point of intersection on the left, well, guess what it's going to be? It's going to be that negative 0.41. If I find the point of intersection on the right, can you stop that? Thank you. If I find the point of intersection on the right, it's going to be that 2.4. Was it 2.41? And if I find the intersection point in the middle, it's going to be x equals 1. Any questions with that one? All right, it's not a long lesson. It's only a couple more examples. Let's take a look now at this example. Now, this one, remember how I said you don't have to worry about showing me how you got the subdomain? This one you have to tell me how you got the subdomain because the argument of the absolute value is not quadratic. Right? Your first equation is going to be x minus 10 equals x squared minus 10x, and this is going to be where x minus 10 is greater than or equal to 0. You can show me how that works, right? You don't need to look at a graph to determine what the subdomain is. It's x is greater than or equal to 10. Because the argument, this thing, is linear, you can do it. If it's quadratic, you can't. You got to do it with a graph or, some other way. Your other equation will be negative 1 times x minus 10 is equal to x squared minus 10x. But this will be where x is less than 0. And now we solve both equations. What do we get here? X squared minus 11x plus 10 equals 0. Just take a minute and roll that around in your noggin to make sure you know how I'm getting x squared minus 11x plus 10. If I were doing this on my own and I were not teaching, then what I would have written is that. But I don't want you to think that I've moved everything to the left just because I write equals 0. I'll go back to having the 0 on the left. And this factors, I think, unless my brain has totally slipped a gear, x minus 10 and x minus 1. Which means the solutions here are x equals 10 and 1. We'll come back to that. Okay? The second equation is negative x plus 10 when I distribute that negative 1 through, equals x squared minus 10x. What do we do here? X squared minus 10x. I guess we're going to add x to both sides. That negative x on the left has got to come over, so we get negative 9x. The 10 has to move over, we get that. I think this is also factorable. Well, that's lucky. It factors into x minus 10, x plus 1, which gives me two solutions here of x equals 10 and negative 1. Now, I used green everywhere, so maybe I'll just separate these two with a line. Everything above that line is the first equation. And the first equation that we solved has that subdomain. These are our two solutions. Is this 10 a solution? Yes. Right? Is this 1 a solution? No, it's not in the domain. Now, I'm going to ask a question. Let's look at the second equation. And it's a bit of an ambiguous question. I understand this. But this is the subdomain, and this is what we are getting. My question is this. Is this 10 that's highlighted in blue a solution?
Should it be x is less than 10, not
Oh,
is less than
did I missed the 1? Thank you. Of course. It's 10, not 0. Yeah. Is this 10 a solution? No, it's not. Don't say, well, yeah, it is because it's a solution here. It's not a solution to this strand of the equation. The fact that it happens to be a solution to the other strand is a coincidence. I don't want you thinking that way. So that, let me get my pink marker here. That is not a solution. Is negative 1 a solution? Yes, negative 1 is less than 10. So there are two solutions, 10 and negative 1. Okay. We had, I'm going to need your help here because I can't see it. I believe we had the absolute value of x minus 10 on the left side, and then x squared minus 10x on the right. Let's go to Zoom Standard because I messed around with my window settings earlier. Well, we should understand that this first function is going to be one of these v's. The absolute value of a linear function is one of the v's. And I can see the left-hand part of the v coming down. It makes sense to me then, just to show this to you, I don't think everybody that you need this shown to you necessarily, but I'm going to anyway. By now you should be familiar with this idea. No. You should be familiar with this idea that you can figure out that this comes down and then back up. This goes here and here. So we need to look a little bit more to the right, and maybe to get a better picture of what's going on, a little bit higher and a little bit lower. So I'm going to go, we don't even need to go from negative 10. I'll go negative 4 to 15. And I want to go down quite far because I think this bottom of the parabola goes down quite a bit. And I'm going to go up a little bit higher. I just want a nicer picture. There's the absolute value of the linear function. There's the parabola. You can see there are two intersection points and only two. If you find the intersection points, you'll discover they intersect at negative 1 and 10, which matches what we got. All right? And again, this is just a nice, I like it. I like looking at it and going, okay, yeah. Even as a teacher, I'm always standing up here and I'm always in the back of my head going, geez, did I do that right? Well, I know I did it right now. And that's how you should feel on an exam. All right, one last question. Is this a subdomain situation that I would expect you to be able to do without graphing? Absolutely, because it's a linear argument for the absolute value. In fact, I would go so far as to say, everybody, that the equation that we get by just stripping off the absolute value signs, you should be able to write x is greater than or equal to 5 without much thought. because x minus 5 is greater than or equal to 0. Are you with me on that, or am I all alone on that? Okay, good. If you need to write, oh, the argument is greater than or equal to 0, and then rearrange it, feel free. And maybe you should on an exam, on a written thing. The other one will be negative x plus 5. And this isn't the first time I've done this, where I've just multiplied it by negative 1 and not showing negative 1 times that thing. And this is where x is less than 5. Again, the equals to component goes on to the first equation. You have to solve this equation, x squared minus 9x plus 20 equals 0. Can you confirm that I have rearranged that correctly? Are there numbers that multiply to give 20 and add to give 9? 5 and 4. It's factorable. That's a breeze now. And this one will be x squared minus 7x plus 10 equals 0. I'm still getting used to using this software, so I hope you understand that sometimes the way I organize things up here is not necessarily the way you would write them down. You're going to organize things wherever you have the workspace you have. My top equation whoops, becomes 0 equals x minus 5, x minus 4. I hope you're in agreement on that. My bottom equation becomes 0 equals another factorable one, x minus 2, x minus 5. In agreement? What are my solutions? My solutions will be x equals 4 and 5, and down here x equals 2 or 5. I don't know if this is important or not, but I'm just going to mention it. 5 is in both. If you get the same number in both, that number is going to be a solution somewhere, because the two subdomains cover all numbers together. I mean, 5 has to be in one domain or the other. Usually if you get the same number in both domains, that's because it's right on the tipping point. It's the same as the number where the domains switch. So highlighting the correct solutions in blue. This 5 is a solution because it is in fact greater than or equal to 5. This 2 is a solution because it is in fact less than 5. So many choices. Ooh, let's do that. This 5 is not a solution because that 5 is from the equation whose subdomain is x is less than 5, and 5 is not less than 5. This 4 is not a solution because that 4 is a solution to the top equation whose subdomain says x has to be bigger than or equal to 5, and 4 is not bigger than or equal to 5. So the two solutions are 5 and 2. And if you wanted to use your calculator, you could confirm that. Any questions with those examples, or that last example specifically? All right, you got a fair amount of time here, at least 15 minutes today to work on these problems. Did anybody try the challenge problem? I'm gonna remind you there is. Did you try it? Okay. The issue is, I'm going to go back and just show it to you briefly. It's a complicated problem, logically speaking, because if you look only at, I'm going to focus my attention right now on this term, okay? I'm going to ignore the other absolute value. This equation becomes the absolute value of 2x plus 1 minus x minus 2 equals 2 if x is greater than or equal to 2. Does that make sense what I've done there? Okay. Let's just walk away from that for a second. The equation also becomes this if x is less than 2. Does that make sense? Okay. But this first equation becomes that. If all I gave you, and I am acutely aware not everybody's going to follow this and understand this, but I know that some of you will. This equation, if I just gave you this equation and I said solve it, you could do it. You'd break it into two equations. Well, that's what I'm doing. The second equation would be negative 1 times 2x plus 1 minus the x minus 2 equals 2 if x is less than negative 1/2. I'm getting the negative 1/2 because 2x minus 1 is greater than or equal to negative 1/2, or greater than or equal to 0. So what happens is you break that original equation into two equations, the green equation and the yellow equation, but then the green equation devolves into two other equations. However, this is the tricky part, and I'm going to end my explanation here and finish this tomorrow. X has to be greater than or equal to 2. This second equation here, look at this. Look at that, what it's saying. It's saying x is, for this equation, x is less than or equal to negative 1/2. Do you see a conflict with this and this? That means you can just not even waste your time on that second equation. It can't have any solutions because it's only valid when x is to the left of negative 1/2, but it falls under the umbrella of x having to be greater than 2. Well, that can't happen. When you solve this equation, it has to be greater than 2, but it also has to be greater than negative 1/2. And then you're going to split up the second equation as well. Give it a shot if you want. It's a real test, especially of the subdomains, if you can do this without just finding the solutions to all four equations and then checking them. That's the easy way out. Doing it with subdomains is more difficult. Anyway, I did want to just give you a lead on that. You can see what the assignment is. Lots of stuff to practice today in the next 15 minutes or so. Basically finish off the stuff in your text, in your handout, and then if you want and still have time on page 389 of your text, there's a question.